In this problem, we're going to be establishing the identity, and we're going to be working with sine of theta times cotangent of theta plus tangent of theta equals secant of theta. So when you're working with these problems, you want to start with the side that is a little bit more complex. So I'm going to go ahead and start with my left-hand side. And all you're going to be doing in these sections is substituting using your identities. And the idea is to prove that this left side is actually equivalent to the right side. So this is going to be where I want to end on that right-hand side. So let's go ahead and work with the left. I'm going to go ahead and use some identities here where I need to. So I've got sine of theta, and I'm going to replace cotangent of theta with cosine of theta over sine of theta. I'll replace tangent of theta with sine of theta over cosine of theta. And now I'm going to go ahead and distribute my sine of theta to each piece here inside my parentheses. So that's going to give me sine of theta times cosine of theta all over sine of theta for my first fraction, and sine squared theta over cosine theta for my second fraction. Now you have a couple different options on how to proceed here. I'm going to go ahead and cancel my sine of theta, one on top, one on the bottom, here in this first fraction. And this is going to give me cosine of theta plus sine squared theta over cosine theta. Now I have two fractions here, and I want to be able to add them together. Keep in mind that the only way for me to add fractions together is if I have a common denominator. So I'm going to go ahead and get a common denominator for my first fraction. Keep in mind that means I need my denominator here to be cosine of theta. And so I'm allowed to multiply this piece by the equivalent of 1. So I'm going to multiply it by cosine of theta over cosine theta. That's going to allow me to get my common denominator here of cosine theta. And on top, I'm going to have cosine squared theta. And now I'm in a situation where I have common denominators, so I can go ahead and add these two fractions together. And when we do that, we only have to write that denominator once. On top, I'm going to have cosine squared theta plus sine squared theta. Remember that we can use identities here. That numerator can be replaced with a 1, because cosine squared theta plus sine squared theta equals 1. So I'm going to get 1 over cosine theta, and I can rewrite this as secant of theta, which is where I wanted to end based on the problem that we started with. So we have proved this identity, right? We proved that the left side, which is where we started, equals the right side.